Welcome to our YouTube channel, Maths Point. In our today's video tutorial, we will be talking about the congruence of triangles. In our last tutorial, we talked about the congruence of figures. At that time, we talked about the congruence of segments. We said two segments are said to be congruent if they have same length. Then we talked about congruence of angles. And we said that two angles are said to be congruent if they have same measure. And then we talked about the congruence between two circles. And we said that two circles are said to be congruent if they have same radii. And at the end, we talked about the congruence of two squares. We said two squares are said to be congruent if the length of their sides is same. Now, in our today's topic, we will be talking about the congruence of triangles and we will see the different criteria by which we can see that two triangles are congruent. Let's see first the congruent triangles. So two triangles are congruent if and only if three sides and three angles of one triangle are congruent, that means equal to the corresponding sides and angles of the other triangle. So it means if we are having two triangles just like here ABC and XYZ, these two triangles will be equal or these two triangles will be congruent to each other if the three sides of triangle ABC are equal to three sides of triangle XYZ and the three angles of triangle ABC are equal to three angles of triangle XYZ. So it is that AB should be equal to XY. Similarly, AC is equal to XZ and BC is equal to YZ. So three sides of one triangle are equal to three sides of other triangle. And angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z. So three sides and three angles of one triangle are equal to three sides and three angles of another triangle. Then we can say triangle ABC is congruent to triangle XYZ. That means the two triangles are having the same shape and same size. And these six equations are called as corresponding parts of congruent triangles, and in short, we are writing them as CPCT. So these were some topics that we read about in our last tutorial, and our focus in today's tutorial will be on different criteria for congruence of triangles. And among them, the first criteria is given as side angle side congruence axiom. That means that this criteria that will tell us that the two triangles are congruent is in the form of an axiom. So it's a proved statement. So there is no need to prove this statement. And the name is side angle side, or in short SAS. And it says two triangles are said to be congruent if two sides and the included angle of one triangle are equal to two sides and included angle of another triangle. Just like we are having here two triangles ABC and XYZ, it says the two triangles will be congruent if two sides and the included angle. That means if the two sides equal are AB is equal to XY, then the second side AC is equal to XZ, then the angle between these two sides, that means here angle A is equal to angle X. So it is the included angle between the two equal sides. So here angle A, and from this triangle XYZ, it's angle X. So we are having two sides of one triangle and the included angle are equal to two sides and included angle of another triangle. Then we say that the two triangles are congruent by side angle side criteria for congruence of triangles. Just like here it is, as this result involves two sides and the included angle between them, therefore it is referred as SAS criteria for congruence of triangles, because it says that two sides and included angle of one triangle should be equal to two sides and included angle of another triangle. That's why it's called as side angle side congruence criteria, and it's also known as SAS axiom for congruence of triangles. Now, there is a note that needs to be remembered for this side angle side congruence criteria, and that is there is very important point in this SAS congruence that the equality of included angle is essential. So it means if the two sides and one angle which is not included angle between the two sides. For example, in this figure, we are having two triangles ABC and XYZ, and if we are having AB is equal to XZ, then AC is equal to XY, and then angle is also given, and the angle given is angle B is equal to angle X. In the triangle XYZ, the side is the included side, but in the triangle ABC, sorry, the angle is the included angle in this triangle XYZ, but in the triangle ABC, the angle is not the included one. So we can't say that the two triangles are congruent because angle B is not the included angle between these two sides. So it's essential to remember that when we talk about the SAS congruence criteria, the angle should be the included angle between the two sides that are equal to two sides of another triangles. Now, there is a statement that must be proven, and we will use this SAS congruence criteria to prove this statement. And it says, prove that angles opposite to two equal sides of a triangle are equal. Two equal sides of a triangle. So it means we are having an isosceles triangle because it is the triangle in which two sides are equal. That means we have to prove that angles opposite to two equal sides in an isosceles triangle are equal. Let's suppose that ABC is our isosceles triangle in which AB is equal to AC. So here it is given that in triangle ABC, AB is equal to AC. Now we have to prove that the angles which are opposite to these equal sides. Here, angle opposite to side AB is angle C, and angle opposite to side AC is angle B. So we have to prove that angle B is equal to angle C. Now let's give the proof. But before giving the proof, we will do some construction here, and the construction will be like this. Through A, we will draw a bisected AD to angle A. That is, draw bisected AD of angle A, which intersects BC at D. So this is our bisector. That means angle A will be divided into two equal parts. So here this angle will be equal to this. So angle 1 will be equal to angle 2. Now let's give the proof. Let's take these two triangles ADB and triangle ADC, and triangle ABD and triangle ACD. We know already that AB is equal to AC as it is given. Then through construction we draw a bisector of angle A. So we got here that angle 1 is equal to angle 2, and here this side AD is common in both. So it is AD is equal to AD, which is common in both. Now we can see that two sides of this triangle ABD are equal to two sides of another triangle ACD. AB is equal to AC, AD is equal to AD, and the included angles are also equal. That is, angle 1 is equal to angle 2. Therefore, we can say by SAS congruence, therefore by SAS congruence criteria, the two triangles are congruent. That is, triangle ABD is congruent to triangle ACD, and when two triangles are congruent, corresponding parts are equal. Therefore, we can say angle B is equal to angle C. Hence, prove it. So we proved that in an isosceles triangle, the angles that are opposite to the equal sides, they are also equal. And we use it, the congruence criteria, which is SAS congruence criteria. Now we have another statement, and which says prove that triangle ABC is isosceles if altitude AD bisects BC. Or it can be said that prove that triangle ABC is isosceles if median AD is perpendicular to BC. We are having this triangle ABC. It's a triangle in which AD is altitude as well as median. And we said that in an isosceles triangle, median and altitude coincides. Now here we have to prove that if this median and altitude coincides, then this triangle is isosceles triangle. So it is given that in triangle ABC, altitude AD is median. That means altitude AD bisects side BC. So it is making 90-degree angle as well as it is making BD equal to BC. That is angle ADB is equal to angle ADC and both are equal to 90 degrees and BD is equal to CD. As we said that perpendicular and this median, these coincide here in this triangle. Now we have to prove that ABC is isosceles triangle. Triangle ABC is isosceles triangle. And isosceles triangle means we have to prove that two of its sides are equal. And we know that in an isosceles triangle, the median and altitude coincides, which is drawn from common vertex of the equal sides. That means the two equal sides should be AB and AC. So we have to prove that AB is equal to AC. Now let's give the proof for this statement. So here we will take these two triangles again, ADB and ADC. In triangle ADB and triangle ADC, it is given that BD is equal to CD, then angle ADB is equal to angle ADC, and then AD is equal to AD, which is common in both the triangles. AD is equal to AD, which is common in both the triangles, and these two statements are given. Thus, we can say by side angle side congruence criteria, these two triangles are congruent. Therefore, by side angle side congruence criteria, triangle ADB is congruent to triangle ADC. And when triangles are congruent, the sides are equal, corresponding sides are equal. Therefore, we can say AB is equal to AC. That means ABC is an isosceles triangle. So we proved that if altitude and median of a triangle coincides, then the triangle is an isosceles triangle. So this was all about our today's tutorial, and in this tutorial we talked about congruence of triangles and we saw one of the criterions which will say us or which will show us that the two triangles are congruent, and that was SAS criteria for congruency of triangles. Thank you, and I hope you understood this tutorial.